Okay, so we found our ceiling today in our understanding of the information mapped on the unit circle. I think we decided we're really good at knowing where the degree measures are. We can figure out where that 30 is a third of this quarter, 60 is 2/3 of this quarter, and that 30 is 1/6 of the half. So if this is pi radians, we can see that 30 is 1/6 of pi radians, or pi over 6. And I think we're getting to understand the distances and how they relate to this special right triangle. So here I have a 30-degree angle in standard position or slope angle position. If the radius is 1, that tells me this y distance is 1/2. There's my y coordinate, and it tells me that this x distance is 1/2 radical 3, or radical 3 over 2. Now those are simply the sine in the case of the vertical distance. Sine of 30 is opposite over hypotenuse. Sine of 30 in this case, where the hypotenuse is equal to 1, is 1/2 over 1. 1/2 divided by 1 is 1/2. So the sine of 30 has a value of 1/2. The ratio of the short leg of a 30, 60, 90 triangle when compared to the hypotenuse is always 1/2. We know that. It's part of our proportional reasoning for special right triangles. The cosine of 30 degrees is always the square root of 3 over 2 divided by 1 when the radius is 1. The cosine of a 30-degree angle is always square root of 3 over 2. Now this distance might be longer in a bigger triangle or a triangle with longer sides, but the cosine is always square root 3 over 2. So we're going to try graphing first the sine data. That's the vertical coordinate information, or the distance along the vertical sides of the triangles. And then we're going to try graphing the cosine information. So to do that, we're going to graph our angles along the horizontal axis. And we're going to do that from a value of 0 to 2 pi. Let's turn off the circle, points A, B, and segment F. I feel like this might be hard to see, but that right there is a distance of pi. So pi being about 3.14, you can see that this distance from 0 to 3 is about the same as this distance from 0 to pi. So let's take a look at where we will graph our sine data when we are at pi radians. So let's go to our unit circle and look at pi radians. Pi radians is this angle right here at 180. Well, there is no height here. So at pi, my value is going to be 0. When I'm graphing sine theta on the y-axis. So sine theta is on the vertical axis, and degrees measured in radians is on the horizontal axis. Sorry, angles measured in radians. Is there any place else where there is no, where the sine is equal to 0? In other words, there is no vertical distance. Well, when the angle is at 0 radians, there is also no vertical distance. So let's graph that information. So sine has the point 0, 0. You don't really need these labels. So I'm going to go to options and say no new objects. And I'm going to turn the label off on C. Okay, so how about at pi over 2? What is the vertical distance at pi over 2? Let's refer to our graph. Pi over 2 is up here at 90. Well, that vertical distance is at 1. So at pi over 2, 1, I know this is going to look like a curve. Wouldn't it be great if, this is 2 pi over 2, wouldn't it be great if at 3 pi over 2, the distance was -1? Let's take a look. Well, at 3 pi over 2, that distance is -1. So we're defining the curve, or the cyclic function, that we call the sine function, simply by plotting its data with respect to the angle measures in radians. So we have at 2 pi, we also have no vertical distance. So let's plot a point at 0, vertical distance. And then how about these points in between? What about at a quarter of pi? Some of you are already thinking that they know what the sine value is at a quarter of pi. So that's pi over 4, or 45 degrees, and that's the square root of 2 over 2. And let's get an idea what that value is by punching that into your calculator. So the square root of 2, value divided by 2, that doesn't look like that went in right. Square root of 2 divided by 2. I don't know how I feel about this calculator. I don't like this calculator, so I'm going to... Oh, hello, scientific calculator. Square root of 2 divided by 2 equals? Maybe you go like this. 2, take the square root, and divide that by 2. Okay, that's how you use this thing. So we're looking for 0.71. We're looking for a value of about 7/10. So at a quarter of pi, that's over here, I need to be up near 7/10. So let's take a look. That's pretty close to 1. And I want to be near a quarter of pi. I did get pretty close to 7/10, but I'm not quite at a quarter of pi. That's pretty good. And now for all of these other quarters of pi, we're going to be at about the same place. And a quarter of pi down here in quadrant 3. Let's take a look. quarter of pi down here in quadrant 3 is also the square root of 2 divided by 2, only it's going to be negative. So we're still looking for a value of around 0.7, only we're looking for negative 0.7. And that'll be true here as well. Negative 0.7 for that value that lives in quadrant 4 at about a quarter of pi. And so let's find the value for a sixth of pi for the sine function. That's this 30-degree angle, sixth of pi. Well, 1/2, that's easy. Okay, so I'm looking for about a sixth of pi on my graph. Sixth of pi, so half of pi cut into thirds is going to give me sixth of pi, and I'm going to be at about 1/2. So that's about here, and at about 1/2 for 2/6 of pi, or 4/6 of pi, that is. So this is 6/6 of pi, here's 7/6 of pi, down around 1/2. Okay, we're getting there. So we're missing now, we've got our 30, or our pi over 6, we've got our 45, or our pi over 4, and we've got, we're looking for our 60. So there's 2 pi, or a third of pi. So let's take a look here. Pi over 3, well that's radical 3 over 2. I don't know how, I don't really know what that is. It's 1.73 divided by 2, so I don't know, 0.8 maybe. So I learned how to use this. 3, square root of 3, divided by 2 equals 0.866. So 0.87, I'm looking to be my sine value for pi over 3 is 0.87. Let's find that point right here. So that's kind of up there, pretty close to up there. And that'll happen again at this third of pi, and again at this third of pi. Oops, I don't have points anymore. Okay, so we've just graphed the data for the sine function for all the values on the unit circle from pi over 6 to 2 pi. And since you're probably doing this on paper, you will just connect those points. Now, because it is a cyclic function and it keeps going beyond 2 pi, this will just simply keep repeating along these same parameters. Now, cosine might start at a different place, so we're looking for the x values or horizontal values. So let's take a look at how these might be different. Cosine at 0 is no longer 0 like it was at sine. Cosine will start at a height, will start at a graph of 1. When we graph the cosine function at angle 0 radian, the output will be 1, which says cosine of theta at 0, cosine of 0 equals 1. So we graph the point 0, 1. Where else is the cosine value, or the horizontal distance, equal to 1? Well, that will be over here at pi. So let's graph that point. And is there a place where it is at negative 1? Oh, that is at pi. Sorry. 2 pi, it's at 1. Here it's at negative 1. So see if you can find the values in between the 1s. for the cosine function.